Alright, let's talk about storage. You know, that thing you're always running out of on your phone or your gaming PC? Now, imagine a hard drive that's practically infinite, lives on the internet, and is managed by the wizards at Amazon. That, my friends, is the essence of cloud storage. We're not talking about your personal cloud drive for a few photos. We're talking about a massive industrial-scale service that powers everything from Netflix to massive scientific research projects. And right at the heart of this revolution is Amazon Web Services, or AWS, with its star player Amazon S3, which stands for Simple Storage Service. It's the go-to place for developers, companies, and even tech-savvy students to dump and retrieve any amount of data from anywhere on the planet. So why should you, a student, even care? Well, think about your final year project. Instead of juggling USB drives or worrying about your laptop crashing and wiping out all your hard work, you could just upload it to S3. It's cheap, it's reliable, and it's a skill that looks seriously good on a resume. S3 is designed to be incredibly durable and available, meaning your data is safer there than it probably is on your own hardware. We're talking about a system built to handle the data needs of the entire internet. And then there's its chilly companion, Amazon Glacier, which is like a digital deep freeze for data you don't need to access often, but absolutely cannot lose. It's perfect for archiving old projects or backups. But first, we need to understand what makes S3 so different from the storage you're used to. Your computer's hard drive uses either file storage or block storage. Think of file storage like a filing cabinet. You have folders inside folders, and each file has a specific path, like c:\users\yourname\documents\project.docs. It's hierarchical and straightforward. Block storage is a bit lower level. It chops up files into fixed-size blocks and stores them wherever it can find space. Your operating system then keeps a map to piece them all back together. This is super fast and great for databases and running operating systems. It's what your SSD is doing behind the scenes. Object storage, which is what S3 uses, is a whole different beast. Imagine a massive, unorganized valet car park. You hand over your car, your data, which is now an object, and you get a unique ticket, an object ID. The valet can park your car anywhere in this enormous lot. When you want your car back, you just show them your ticket, and they bring it to you. You don't know or care where it was parked. Each object in S3 is a self-contained package holding the data itself, some metadata, and a globally unique ID. This system is incredibly scalable and flexible, making it perfect for the unstructured data that dominates the modern web, like images, videos, and log files. So, how do you actually use S3? It all starts with a bucket. An S3 bucket is like a top-level folder or a container where you store your objects. The first thing you need to know is that bucket names must be globally unique. That means no one else in the entire world, across all of AWS, can have a bucket with the same name as yours. So, my test bucket is probably taken, but something like Linus Project Archive 2025-06-23 has a better chance. Once you've created your bucket in a specific AWS region, like Mumbai or Ohio, you can start chucking your files or objects into it. There's no limit to the number of objects you can store in a bucket. It's practically bottomless. Every object you upload to an S3 bucket is made up of a few key components. First, there's the key, which is simply the name of the object. For example, if you upload a picture named cat.jpg into a bucket called mypetphotos, the key is cat.jpg. You can also create a folder-like structure by using slashes in your key, like videos/vancouvertrip/day1.mp4. Technically, S3 doesn't have folders, but it uses this naming convention, called a prefix, to help you organize things. Then there's the data itself, the actual bytes of the file. And finally, you have metadata, which is data about your data. This includes system-level stuff like the content type and size, but you can also add your own custom tags, which is super useful for searching and managing your objects later. So you've uploaded your file. How do you get to it? Every object in S3 can be accessed via a unique URL. This URL is typically formed using the bucket name, the region, and the object key. This means you can directly access your files from a web browser or use these URLs in your applications, provided you have the right permissions, of course. The basic operations you'll perform are pretty much what you'd expect. Put to upload a new object or overwrite an existing one, get to download an object, and delete to, well, delete it. These simple commands are the foundation of interacting with S3, whether you're using the AWS Web Console, a command line tool, or writing code with an AWS SDK. Now let's talk about what makes S3 so freaking reliable. AWS advertises an insane durability of 11 nines, That's 99.999999999% for objects stored in S3. What this means is that if you store 10 million objects, you can expect to lose a single object, on average, only once every 10,000 years. They achieve this by transparently storing your data across multiple physical devices in multiple facilities within a region. So, even if a whole data center goes offline because of a flood or a rogue forklift, your data is still safe. On top of that, S3 offers high availability, meaning it's designed to be accessible 99.99% of the time. Your data isn't just safe, it's almost always there when you need it. Having incredibly durable storage is great, but it's useless if your data gets into the wrong hands. Security on AWS is a shared responsibility. AWS secures the cloud infrastructure, but you are responsible for securing what's in the cloud. By default, all your S3 buckets and the objects inside them are private. Only you, the account owner, can access them. This is a fantastic security posture to start with. The most common mistake people make is accidentally making their buckets or objects public, so always double-check your settings. The block public access feature is enabled by default on new buckets for this very reason, acting as a powerful safety net to prevent accidental data leaks. To control who can do what with your buckets and objects, S3 provides several powerful access control mechanisms. The primary method is using AWS Identity and Access Management, or IAM. With IAM, you can create users, groups, and roles with very specific permissions. For example, you could create a policy that allows a specific user to only read objects from a certain folder within a bucket but not delete them. For simpler object-level permissions, you can use access control lists or ACLs, though IAM policies are generally the recommended and more flexible approach. Bucket policies are another tool. They are JSON-based documents you attach to a bucket to grant permissions across the entire bucket, which is great for setting broad rules. Let's not forget about protecting your data while it's in transit to and from S3, and while it's sitting there at rest. For data in transit, you should always use SSL or TLS encryption, which is as simple as accessing S3 via an HTTPS endpoint. This prevents anyone from snooping on your data as it travels over the internet. For data at rest, S3 offers multiple encryption options. The easiest is server-side encryption with S3 Managed Keys, or SSE S3, where Amazon handles all the key management and encryption for you. For more control, you can use SSE KMS, where you manage the keys through the AWS Key Management Service, or even provide your own encryption keys with SSEC. Now, what about that pesky "oops, I deleted it" moment? S3 has you covered with versioning. When you enable versioning on a bucket, S3 saves every version of an object you ever upload. If you overwrite an object, the old version isn't gone. It's just hidden. If you delete an object, S3 just inserts a delete marker instead of actually removing the data. This means you can easily restore previous versions or recover from accidental deletions. To add an extra layer of security against malicious deletions, you can enable MFA delete. With this turned on, anyone trying to permanently delete an object version must provide a code from a multi-factor authentication device, making it much harder for an attacker with stolen credentials to wipe your data. Once you've mastered the basics, S3 has a ton of advanced features that can save you time, money, and honestly, a lot of headaches. One of the most powerful is Object Lifecycle Management. Let's say you're logging application data. You probably need to access today's logs instantly, but logs from last month are less important, and logs from last year are purely for archival purposes. Instead of manually moving this data around, you can set up a lifecycle policy. This policy can automatically transition objects to cheaper storage classes after a certain period. For example, move objects to S3, infrequent access after 30 days, and then archive them to Amazon Glacier Deep Archive after 365 days. You can even set rules to automatically delete old objects completely. Another cool trick is using S3 to host a static website. A static website is one that's just made of HTML, CSS, JavaScript, and image files. No server-side code like PHP or Python. You can configure an S3 bucket to serve these files directly to a web browser. Just upload your index.html and other assets, enable the static website hosting feature, and AWS will give you a public URL. This is an incredibly cheap and scalable way to host a portfolio, a blog, or a simple project website. You don't have to manage any servers. S3 handles all the traffic, whether you get 10 visitors or 10 million. It's a fantastic way to get a web presence up and running for pennies. Let's talk about managing massive datasets. If you need to upload a huge file, Like a 100 gigabyte video render, doing it in one go is risky. If your internet connection drops at 99%, you have to start all over again. This is where multi-part upload comes in. It allows you to break a large object into smaller parts and upload them independently in any order. S3 then reassembles them on its end. This improves reliability and allows for parallel uploads, which can significantly speed things up. The reverse is also possible. If you only need a small piece of a giant file, you can use a range get request to download just a specific byte range of the object instead of the whole thing, saving you time and bandwidth. Finally, S3 has features for building robust, enterprise-grade applications. Cross-region replication, or CRR, automatically copies objects from a bucket in one AWS region to a bucket in another. This is great for disaster recovery or for reducing latency for users in different parts of the world. Event notifications can be configured to send a message using services like SNS or SQS, or trigger a Lambda function whenever something happens in your bucket, like a new object being uploaded. This allows you to build powerful automated workflows, such as automatically creating thumbnails for any image that gets uploaded. And of course, you can enable detailed logging to track every single request made to your bucket, which is crucial for security audits and troubleshooting. Sometimes you have data that you don't need to access quickly, but you absolutely must keep it safe for the long term. This is for things like legal documents, medical records, scientific data, or just old project files that you might need someday. Keeping this kind of data in a high-performance storage class like S3 standard would be a waste of money. It's like paying for a Ferrari just to keep it parked in your garage. This is exactly why Amazon created Amazon Glacier. It's a secure, durable, and extremely low-cost storage service designed specifically for data archiving and long-term backup. Think of it as the digital equivalent of putting your valuables in a bank's vault. Glacier offers several retrieval options, which is how it keeps costs so low. Unlike S3 standard, where you can get your data in milliseconds, retrieving data from Glacier takes time. The options range from expedited retrievals, which can get your data in a few minutes, though for a higher price, to standard retrievals, which take several hours, and bulk retrievals, which are the cheapest option but can take up to 12 hours. There's also S3 Glacier Deep Archive, which is even cheaper than Glacier, but has a default retrieval time of 12 hours. This trade-off between access time and cost is the core concept of Glacier. It's for data you plan to store for months or more likely, years. So, when would a student use this? Imagine you've completed 4 years of university projects, including massive datasets, video files, and code repositories. You don't need them on your laptop anymore, but you don't want to delete them forever. You could bundle them all up into a single zip file and upload it to S3 Glacier Deep Archive. It would cost you pennies per month to store terabytes of data. Years later, if a potential employer asks to see your old work, you can initiate a retrieval, wait a few hours, and have all your files back. It's the ultimate digital attic for your academic and personal history. In conclusion, learning AWS S3 and Glacier isn't just about understanding some niche cloud service. It's about learning the fundamental building blocks of the modern internet. S3's object storage model is the backbone for countless applications, and understanding how to store, secure, and manage data at scale is a critical skill in today's tech landscape. From hosting a simple website for your resume to building complex, data-driven applications, S3 provides the tools you need. And with Glacier, you have an incredibly affordable way to archive your digital life securely. So go on, create an AWS account, play around with a free tier bucket, and start building. The skills you learn will be invaluable.